The topic of this week's discussion quiz is related rates. So below I have a problem with a part A and B that relate to each other. So to start with, we're actually given the formula for the area and circumference of a circle based on the radius. Part A says, suppose that the radius of a circle is decreasing at this rate, 5 centimeters per second. Can you use this information to figure out how fast the area is changing when the radius reaches a length of 2 centimeters? For this problem, just to be careful, I'm going to define all my variables. So clearly r is going to be technically it's the length of the radius. And the units on that are going to be centimeters. I'm noticing that centimeters is the length that's presented in the problem, so that'll be the length of my radius. I'll also define A, that's going to be the area of the circle. And the units on this are going to be square centimeters, so centimeters squared. So since I've defined my variables, I'm going to also write down, well, what is dr dt? And also we'll figure out what is dA dt. dr dt is the rate at which the radius is, in this case, decreasing. And the units on this are going to be centimeters per second. In fact, this number is stated within the problem. It's 5 centimeters per second. The decreasing means it'll be a negative value. So I'm going to note that dr dt is actually equal to -5. So it's up to us, if you see language that indicates something is decreasing, to include a negative in the derivative. The thing that we want to solve for is the rate at which the area is changing, and this is dA dt. So this thing we don't know. We're trying to solve for it. I know the units should be square centimeters per second, but I'll note that this is the rate at which the area of the circle is changing. So the goal is now, all right, how can I relate area and radius and then get these expressions here? I'm going to use this formula. So I'll note that I know that A is equal to pi r squared. If I differentiate both sides with respect to t, I get the following. dA dt is equal to 2 pi r to the first times dr dt. And this dr dt comes out by the chain rule. Once you have this expression, we've connected this to this, but it also depends on r. In this case, we're asked about when r is equal to 2. So that is, when r is equal to 2 centimeters, can we figure out what dA dt is equal to? I'll simply plug in all of the numbers that we know. So we have that dA dt, when you evaluate it with r is equal to 2, we have 2 pi, r is 2, dr dt is -5, and the units on this are going to be square centimeters per second. If we multiply all of this together, the answer is going to be negative, and so we have, so it's -10, -20 pi. So this is -20 pi square centimeters per second. So to put this all together, here's the exact answer. I'll say the area of the circle is decreasing at a rate of 20 pi square centimeters per second. The second part of this question is related to the first. So this says that at some point, the above circle that we were working with, it was first decreasing, but now it begins to increase in size. If we know the circumference of the circle is increasing at a rate of 2 centimeters per second, how fast is the radius changing when the radius reaches 10 centimeters in length? So for this one, again, I'm going to start by just carefully defining my variables. R is the length of the radius, that of course is going to be in centimeters. C, now that's different. This is the circumference of the circle. And the units on this are actually also centimeters. Circumference is a length, it's not an area or a volume, and that's the distance around the circle, so it has to be actually the same units as this thing here. With these two variables defined, again, we can say, well, what is dr dt and what is dc dt? Dr dt is the rate at which the radius is changing. Notice that the radius is the thing that we're solving for, and I'm going to use the same language that appears here. We're trying to solve for dr dt. And I know the units on this is going to be centimeters per second. The other thing is, well, what is dc dt? This is the rate at which the circumference is, in this case, we're stated that it's increasing. And I know it's going to be centimeters per second based on the units in the problem. So we're actually given here that dc dt is equal to, and that number is 2. So 2 centimeters per second. And it's positive because the variable c itself is increasing. Can we choose an equation that connects c and r to figure out how these two rates connect to each other? So that formula is stated in the problem. That is, the circumference is equal to 2 pi r. If I differentiate both sides with respect to t, dc dt is equal to 2 pi. This time, since you're just taking the derivative of r to the first, we have dr dt. There is no need to use a power rule in this case. So the goal is, I'd like to figure out this, and we were given this. We're also told that the radius when it equals 10 is relevant to this question, but actually there's no r to put this number into. So really, this number turns out to be irrelevant in terms of differentiating this equation. Here I'm going to put 2, I'm going to divide it by 2 pi, and that'll give us the answer of dr dt. So that is, okay, we have 2 is equal to 2 pi dr dt. If you divide both sides by 2 pi, so divide by 2 pi, they cancel on the right, the 2's on the left cancel, you get 1 over pi, and this is equal to dr dt. And just to be careful, just to write units next to this, this is centimeters per second. So maybe I'll just write that over again so it can fit. The answer, the exact answer, is 1 over pi centimeters per second. This means the radius is increasing at a rate of 1 over pi centimeters per second.